So, at the beginning of every mod, every chapter, they're going to look at some skills that are helpful for you, um, so that you don't get hung up on the algebra. So I try to always review those skills just so that we're on the same page, and any algebra stuff that I know you might struggle with, I'm going to try to remind you those rules. So when you're done with this, you're going to turn this in. So just do this along with me. So problems 1, 2, and 3, it says to evaluate the expression given the values that they've said. So we're going to start with number 1 here. My suggestion to you, when you place into the expression negative numbers especially, I would use parentheses to your benefit, okay? So, but the first one doesn't use any of the negatives. It has told us that C was 5, A was 4, and B was 11. So just go ahead and put those things in there. Now, just follow order of operations. So you're going to do the square root of 5 minus 4. So do that value first. The 5 minus 4 would get done. You'd get 1. The square root of that is 1. And then that would be 12 over 2, or a value of 6. So you guys probably remember how to do that. The most often seen mistakes for me is plugging in negatives. So you probably are good with 1. Now let's move on to 2. Where we see A, we're going to put a 4. Where we see B, we're going to put an 11. Now, even if I'm going to plug in a positive or a negative, if it's referring to a square, I will usually leave a parenthesis to place that thing in. It just kind of will make things flow pretty good. And so if you see this one, let's follow order of operations. A fraction bar is considered a grouping symbol. So you're going to do the top, you're going to do the bottom individually before you get an answer, okay? So we're going to get 5 minus 4 on top, 121 minus 11 on the bottom. Get a final answer on top and a final answer on bottom before you decide to start canceling things or doing anything else. We get 1 on top, we get 110 on the bottom. Now, there's nothing else we can do to that fraction. I do like fractional answers. Don't worry about giving me any kind of like decimal of any sort, okay? Now we move on to 3. Now this time we're actually plugging in a negative, so watch that. So this is going to be negative 4, the square root of negative 4 plus 6 over negative 4 plus 6. Yeah, I mean, you're just going to do it very quickly. As you can see, that top is going to still contain a square root of 2, because you're going to get that value of a 2 inside there. You're just going to leave it alone. Well, yes. So this is the way I always think of it. If you end up with things in the square root and things not in the square root, they're kind of almost two separate problems. So the bottom here got a 2. So only compare those things. So the outside stuff with the outside stuff, and the square root stuff with the square root stuff. So the square root of 2 does. It just kind of hangs along for the ride. And so what we get is negative 2 square root of 2. So leave the outside stuff kind of as one problem, and then the square roots attached to it. Now, there are obviously some rules of reducing radicals that we'll talk about when necessary, when that part comes up and when we need to. So like if we had square root of 50, we might have to reduce it down a little bit. But for this particular purpose, that square root of 2 kind of just became almost like its own little thing that it just kind of came along for the ride. So those are some evaluating expression skills that most likely that wasn't anything, unfamiliar. Do we have any questions about 1, 2, or 3? Okay, now let's talk about 4 and 5. It says in exercise 4.7, use the given information to write an equation and then solve it. So what they want for you to do initially, so please follow the instructions. First, they say to solve that for x. And it says if y is equal to 5. So we're going to do it in that order. So if I were to solve this equation for x, I first would add 19 to both sides, and then I would divide by 2, right? We have to get rid of that 2. Now, when you divide by 2, just put that over 2. And then they want us to solve it if y is 5. So now we're going to take out the value of 5, or the y sitting there, and replace it with a value of 5. So we get 5 plus 19 over 2 is equal to x. 5 plus 19 is 24. Divide that by 2, and our x value is 12. Now, you could have technically plugged in a 5 and then solve it. You should get 12. If you don't get 12, take a look at what happened. Why didn't you get 12? But you would get 12. Okay. Everybody good with number 4? Now, let's do the same thinking for this. We're going to solve it for x, and then we will plug in y equals -2. So first, if we solved it for x, what is the opposite operation of cube rooting something? What is the opposite? Cubing it. So if it's a square root, now the thing to remember, that inverse operation is to square something. But a cube root's inverse operation is to cube something. So we're going to cube both sides. Please surround the entire side with parentheses when you do that. So let me show you what I mean. The reason you want to get used to showing the entire side in the parenthesis is because if our side was more complicated, it will help you so that you probably won't make some mistakes. So just put a parenthesis around each side and put a little cube on it. Now, what's going to happen on the right is that the cube root will disappear, and that's what we wanted. We want to solve for x, and so we get that x is equal to y cubed. Here's a good one. When we plug in that value of y they gave us a value of y as -2. Put that -2 into parentheses so that you remember to cube it, because, just a little hint, -2, it's really even powers that can mess this up. -2 to the 4th is +16. -2 to the 4th without the parentheses is -16, and that's where they get you. Now, this is a cube. A cube of a negative is negative, whether it's sitting outside or inside, because those 3 things. So our answer for this one is -8. But it's a good idea to get into the habit of using parentheses, because if that would have been an even power, when we actually used it, that negative would have then disappeared. Everybody good with 4 and 5? Everybody good with 4 and 5? Okay. Now, let's talk about 8 and 9, solving each equation. You've been solving equations since probably pre-algebra or algebra 1. So I know you know how to solve equations. It's not something that I worry about necessarily. But as we get into the course more, and as you get prepared for calculus, the equations can become more complicated. So I will show you tricks along the way that I've always thought were very helpful in fixing some of the issues. And one of the issues I see with 8 and 9 are fractions. And a lot of you, just your fraction skills, you avoid fractions, or you don't like fractions, or you're not good at fractions. And if you're the exception, use your fractions, but I'm going to show you a little rule. If we multiply an equation through by the common denominator of all the fractions we see in the problem, your equation instantly becomes 90 million times easier to solve, okay? Now, this is why. In an equation, you have the power to multiply through by whatever you want, or divide through by whatever you want. So if we actually take and multiply through by our least common denominator, 6, so it has to be the least common denominator of every single fraction within the problem, because that's 6 over 1, anything on the top gets multiplied by 6, and then we get to divide off the bottom. So let me show you what I mean. Well, if we think about this multiplying here, that would be 2 times 6 divided by 3. Well, 2 times 6 is 12. Divide that by 3, get 4. So that's 4x. Let's do it again. This would be 6 divided by 2, 3. And this would be 17 times 6 divided by 2, which essentially then just becomes 17 times 3, which is 51. Look how much easier that equation just instantly looks by taking one extra beginning step to manipulate it before you start moving things around and doing everything like that. So in this case, you would subtract 3 from both sides, which gives us that 4x equals 48. If you divide by 4, you get x is 12. Now you can check your work. 12 times 2/3 plus a half should be the same decimal as 17/2. I mean, you can check your work like any other equation. I would check it in the original because that would show you if you made any mistakes in that first transition part. Okay. Any questions about 8? Now, there are more than one ways to do that equation. I'm just showing you kind of a little trick to make it kind of flow a little nicer. But if you just jumped in and did the fractions, you go for it. Let's look at 9. I'm going to show you another little trick. This 1/5 is multiplying by 1 complete side. To divide it off, all we have to use is the reciprocal. It kind of is the same thing I said before. If you have a fraction in the problem, just multiply through by its common denominator, and that will fix it. So let's just multiply everything through by 5. By doing that, we get 20 equals. Now what's great is 5 times 1/5 is 5/5, or 1. That's the glory, wonderfulness of multiplying by reciprocals. You're always going to get 1. And so then on the right side, the only thing we have left is that quantity. We don't need the parentheses anymore because there was a 1 sitting there. You can almost think you've distributed the 1. There's no need for the parentheses. And now it's just an equation. You get 27 equals 3n, so n is equal to 9. If you put it back into the original, the very, very original, you get 1/5 of 20, which is actually 4 that was on the page. So, it works out. It should always work out back in the original. And so even taking a second and checking it yourself in the original helps you find any errors that might have occurred. Do we have any questions about 8 or 9? Okay. Now, in exercises 12 to 16, they say they want us to write an equation based on the description, and then we're going to solve the equation. So what I want to do is I want you to break down some things with me. So I'm going to use some highlights, so if you want to do that as well, that might help you as you go through these. Back in Algebra 1, Algebra 2, you might not have been really good at those interpreting the word problem and then making it into equations. So let me show you some hints. Here it says the sum of. Well, the sum of what? Well, the sum of 3 times some number in 12 is, that's always a good kind of a separation place, and then 42. So I'm kind of breaking it down in a way that can help you to kind of really visualize what's happening here. Yeah, the sum of, that's where you got the 3x, whatever you want to call it, plus 12 is 42. So, don't make these harder than they are. They're pretty straightforward, okay? But now solving it, you would subtract the 12 so that you isolate that 3x term, so that we can then essentially, last step would be to divide off the coefficient. And so if we divide by 3, we get 10. And then you can check 3 times that number plus 12 should equal 42. 3 times 10 is 30 plus 12 is 42. So then you can easily plug it back into the original statement and then you find your number, okay? And you didn't have to call it X. Sometimes I've seen, since they call it a number, people use N. That's okay. You can use whatever variable. If they haven't specified, make the variable you want. Everybody good with 12? Okay. One last one. Let's do the same thing. I'm going to kind of highlight for you. The difference between, what mathematically are they talking about when they say difference between? Yep. And go in the order that they say. And then they said between some number and 14.3. Then we got our is, and then we've got 2.1. Yep. Yeah, they didn't even change the number this time, did they? They just said some number. So we'll call it X minus 14.3 is 2.1. And then you're just going to then add 14.3 to both sides. So we get X is 16.4. And you can, if you said, oh, the difference between 16.4 and 14.3 is 2.1. If you replace it where they said the word some number, it should make sense. If it doesn't make sense, then something happened along the way. Something is wrong, okay? Everybody good with that? Please turn in your mod 3.0 investigation in Google Classroom. And then as soon as you've turned that in, could you please open up the pre-class M31 in iMath? Open up your pre-class M31 in iMath. It's about functions and modeling functions and relationships between quantities and functions. So open up your pre-class M31. We're going to take a moment and we're going to talk about that, okay? Now, the pre-classes are just kind of giving you a sense of what's coming, introducing you a little bit to the topics. I'm going to try to start doing, even besides just the investigations, I'll try to throw these, that we can walk through some of these together, okay? But on the top of your page, did everybody find it? Everybody in that spot? Okay, pre-course M31. I think it might be showing up on Monday if you looked at the calendar. What they're trying to get through here is, they call this the pathways problem solving process. And I will tell you, you know, iMath is what iMath is, but I agree the fact that this is a really valuable thing to do. And you might have noticed I've kind of done it from the start. The first thing they talk about is reading that problem thoroughly. And I am notorious for sometimes going too fast and kind of skimming and pulling out the information and not necessarily answering what they want, and then going back and going, oh, okay, that's what they wanted. So that reading process is very helpful. Next thing you'll notice, when I was doing those problems, like when Lisa was walking one way and you know the other person was walking another way and they're meeting in the middle, remember I always drew that picture. As you get ready for calculus, drawing that picture becomes so super important. Defining a variable to represent the value of the independent quantity. Usually that's going to be your X. Many times in an application problem, it might be your time that has passed. Construct an expression in terms of using that independent variable, and then we get to define a formula. We've been doing this. That's not super, you know, something that should surprise you. Okay, so let's take a look at the first question in that they ask us. It says a window manufacturing company sells windows that are in the shape of a half circle with the length of the base of the window B. Now, it says that B is forming the diameter of a circle. So we've read that part. I would initially draw what's happening. So we've got this little half circle. So if you have a sheet of paper, you might always want to kind of have a little sheet of paper next to you, or open up a little notability window next to you so you can draw a picture. Remember, that was one of that problem solving process that they wanted you to go through. And they called this B. Okay. So it says, make a drawing that represents the quantities in this problem and context, and how are they related? Label B on your drawing. So how are they related? We're going to get to that in a second, but you can just say that you did that. Hopefully you have done that along with me and drawn your little picture. Okay. Now it says, write an expression. Now expression, remember, means that it's just no equals. It's just an expression that would represent the window's perimeter length in inches, or the length of the frame of the window in terms of the length of the base of the window in inches. Okay, so let's look at this picture for a minute. Does anyone remember the equation for a full circle? What is the equation for a full circles? If we had a full circle, what is the equation for the circumference or perimeter of a circle? So 2 pi r is real common. Another one I'm going to use just because it will save us a step. You can use it in terms of diameter, that the circumference is 2 pi r. I'll write that one because that's a good one. But it's actually then just pi times the diameter, right? Because two radiuses is equivalent to our diameter. Okay. What do we know? So that's the formulas we're going to kind of use to help us. How much of the circle is this? Half. How big is the diameter of this? B. They just gave it B, okay? So in this particular context, this green section, the perimeter of that green section, that circumference of that half circle, is half of the diameter, I was going to say, half of the perimeter. So it's half of pi times B. Now, let's think about if you were making the window frame. That's this part. But what do we have to add on to it? That bottom part, that B. And so the total perimeter, the expression you're going to put right here, is 1/2 pi B plus B. Okay. Now, use that little equation thing, that little yellow box, so you can put that stuff in. Those are not like terms. We cannot add them up. Do not add them up. You cannot. So the formula then flows pretty good. It should just be P equals 1/2 pi B plus B. Now, for those of you that are, working in your iMath, doing this pre-course, the little blue hint button, if you're stuck, use that as a tool to get you going, get you in the right direction. Everybody okay with A, B, and C? Everybody got A, B, and C done? Okay, now let's go to D. It says evaluate the formula when B is 21.5. Hey, great. We have now some numbers to plug in. So P would equal 1/2 times pi times 21.5 plus 21.5. Now, we're going to have to play with what they want us to enter. Pi is that irrational number. So I'm just going to leave the pi there for a minute. 21.5 times 1/2 is 10.75. So I'm going to enter, I want you to enter this and you can tell me if it's right, okay? 10.75 pi plus 21.5. Could you guys enter that and tell me if it is okay with that? And I think where the pi is sitting, you can type out pi, and I think it's going to be okay. Go ahead and try it. All I did was stick in the B into our formula right here. And then you guys tell me, did it work? Did it turn green and say everything's wonderful? If you typed in 10.75 pi plus 21.5, what does it say? Is it good with it? Oh, you have different numbers. Okay, use my idea, and if you plug in my idea, tell me, does it work? It is correct? Okay, great. What does our number represent? So I was hoping that you guys even had the same numbers this time. I'm sorry. What does your answer represent? So that is the entire length of the base of the window plus the perimeter of the window. Let's see, what is that number coming up to be for me? So we know everybody, well, no, I don't know if your base is 21.5 or whatever it is, but it would be, for me, um, it would be this one. For you guys, I don't know which one it is, but the base of the window should be the small number, and then the corresponding perimeter. Wait a second. The length of the base is 21.5, and the corresponding perimeter of the window is 55.27. Yes. So I think your small number would be first, and your perimeter, your larger number should be the perimeter second. Okay. And then it says in E, write a formula to find the length of the base of the window in inches in terms of the perimeter. Okay, so let's go back. This one's hard. I'm going to write this formula down. Everybody does have the same formula, right? So let's do E together. These two terms, 1/2 pi b plus b, are not like terms. We can't mush them together. When that happens and you want to rewrite a formula, but that occurs, you always do the same thing. You take out the b from both pieces. Now, if there was just a b there, b divided by b is 1, so you have to have a little 1 placeholder, but we take out the b from both places. The reason we do that now is we only see 1b in the equation, so now we can divide off, and so the thing that you would enter into your iMath is that b equals the perimeter divided by 1/2 pi plus 1. Okay, so that is a technique. In calculus, there's this one technique we do, it's called implicit differentiation, and that technique happens a lot in those problems. So that is something that's going to happen algebraically. If your terms are not like terms, that's okay. Factor out that variable, and then whatever's in parentheses, divide. Okay? And if the perimeter is 55, now your number might be different than my number, so be careful. What is the base? Well, we have a nice formula. So we're going to take the 55 and place it in. Yours might not be 55, whatever yours says on the paper. And we're going to divide it by 1/2 pi plus 1. Use parentheses to help you if you do use a calculator. I got 21.394. I got 21.394. Okay. So that's your first one. You know, your numbers and my numbers might be different, so you might need to adjust accordingly. Do we have any questions about that first section of the investigation? Okay, I know, it's weird. Okay. All they're talking about in this section here is that you should know how to look at something on the Cartesian plane. They're not saying much more than that. And let's look at the golf ball question. Okay. So the following graph represents the height of a golf ball in feet. So I'm going to put feet over here to remind me what they told me. And in terms of the number of seconds, see how that in terms of, that means that's our x, or our independent variable. This is seconds. That has elapsed since the golf ball was hit, and they're called that t. Height is h, which conveys what the point 345 represents. So I would actually make yourself a little note that it's going th It's going seconds and feet. So all they're really saying is, what does that mean? Well, that means that at 3 seconds, 3 is your seconds, 45 is your feet. At 3 seconds, we're at a height of 45 feet. So it is a record of the ball's height 3 seconds after it hits, or whatever your first number was. And it was the simultaneous values of t and h that are in the relationship defined by the graph. And this last one for me, the ball's height from the ground was 45 feet 3 seconds after the ball was hit. So just make sure that the 3 is representing seconds and the 45 is representing feet, or whatever your point pair was. The first number are your seconds, the second number are your feet. As the time since the golf ball has hit increases from 0 to 2.5 seconds, the height of the ball does what? Okay, so all you're going to do here is I would take and visualize from 0 to 2.5 seconds. Is our height going uphill or downhill? It's going uphill. So it's going to be increasing. Is that the option? Increasing, decreasing? It's going to be increasing from 0 feet, because that's the 0.00. Yours might be different than mine, but mine goes up to, would you say it looks like about 47 for me? So estimate whatever yours happen to be. Mine's not quite at the halfway point. It looks just slightly under. So I'm going to go for mine 47. And on what time interval is the ball's height decreasing? It's decreasing from 2.5 seconds to 5 seconds. So that's all they want there. Now, we're going to talk more about interval notation next week, but from 2 seconds or 2.5 seconds to 5 seconds is interval notation. For increasing and decreasing, just use parentheses. That means just on the other side of 2.5, it's starting going down. It's going all the way to 5. 5, it hits the ground, so it's not really doing anything at 5. And then at what time is the golf ball 0 feet above the ground? There's multiple times that our height is 0. So just look at your graph. Mine is 0 and 5. Yours might be times of something else. Is yours similar to my graph? Is it similar? Okay. Any questions that we have on the golf ball problem? Okay, I'm going to leave that there for a second. Again, please note if your and my numbers are a little different, account for that. But hopefully this will walk you through that. And then finally, this is just talking about using a formula, solving an equation related to the formula, and I'll walk you through the Sarah and Lisa walking problem. We've done this problem and versions of this problem. You're going to see the candle problem might come back, some of those other things we've already done. So it says that you can drag the things, okay? And you can even click to animate. Of course, I can't do that. Mine's just a PDF version of what you're doing, okay? So I'm going to make myself a little note over here that X is the amount that Lisa walked. And Lisa is walking toward Sarah. They are 80 feet apart. And they walk toward each other. Sarah travels the same distance. So if X is the amount that Lisa has walked, then they say Sarah is doing the same amount. So they are both X. So a formula is what we want for A, and it says find a formula to define the distance between them in terms of D if D is the feet that's left between them. So we would have here a formula that represents the distance between Sarah and Lisa in feet, in the terms of the distance X that Lisa has walked. And so it would be 80 minus off the two X's that they've come together. So that's that total, okay? Evaluate the above formula of 25.5. Your number might be different, but you're just plugging in to the formula. And in my case, I get 29. And what does your answer represent? The distance between Lisa and Sarah when Lisa has walked 25.5. It's this one. And then on the graph below, construct a graph of the axes below to represent the distance between them. Okay. So, and then plot the point on the graph where they have walked 5 feet. Okay. So they each start at 80 and eventually will get to 0. And it's going to look something like that. So first put on the graph. That's what they've asked you to construct a graph. We are using 80 minus 2x. So, or 80 minus 2t. No, they did call it x. So our slope is -2. Our y-intercept is 80. You could also think about the fact at time 0, they're 80. And they want time 5 anyway. So let's see what's happening at 5. If you plug in 5, and I don't know if they said 5 on yours as well, but on mine, 80 minus 10 is 70. So now use that little point feature and go to the point 570. It should hit the line or your line is wrong. But you have a formula. Plug in 2 points. 2 points create a line. I plugged in 0 because that's a nice number to plug in. I plugged in 5 because they asked me to do that anyway. And then use that point feature. And then it says use the graph to determine how far Lisa has walked towards Sarah when they're 50 feet apart. So at 50 feet, that's this. That's the X they're looking for. So they're asking what number, what X goes with 50. So if you go to your graph and hit 50 and go down, the X value is 15. So hopefully that has helped you do this pre-course, okay? Please, if you didn't finish it right now, that's really the only thing you need to work on this weekend. But the more you get caught up in your iMath, if you have a day where you're busy or you have something else, you're caught up. You can't let these things go by. You got to keep yourself caught up, okay? So, and I will post this so that you have it. There you go.